Good morning, everyone. Thanks for coming through. So I'm going to get right into it because we've got a lot of slides that we're going to try to burn through, and hopefully we'll get through all of them. Lots of slides, lots of demos, so I'll be speaking quickly for the most part. So really quick introduction. I'm Harun. This is Marco. We're from a small company called Thinkst. There's not much value in going into too much of detail, except, of course, for the fact that both Marco and I have been doing pen testing and general offensive stuff for a really long time. So most of the stuff that we're looking at today, although it's a defensive talk, is largely, to use the stolen phrase, defense strongly guided by offense. Okay, and that's kind of what we're going for. Really quickly, a plan for what the talk's going to be about or how we're going to do it. We're going to spend a few seconds literally on history because most of you have that bit. We're going to try to talk about why honeypots have failed, like why we're not seeing as many of them as we believe we should. And then we're going to talk about stuff that currently hinders adoption. And at reasonable points along the way, we'll show you technology that we've built, technology that we are putting up for you guys to use, so that hopefully you don't have these stumbling blocks. So really quickly, some history. If you're going to do a talk like this, the first thing that comes up is this clearly isn't new. If you hit our conference collector site, you'll see we're tracking around 155 talks that have been given just on honeypots. So clearly the stuff isn't new. And if you're talking about deception in warfare has been around for a really long time. Like it probably goes all the way back to the garden. The military have been using it for long enough. The Joint Chiefs, Chief of Staff, have a document out called JP 313-4, which effectively talks about military deception and its uses on the battlefield. It's really interesting. It's really worth reading and going through. But essentially what they categorize it as is those actions executed to deliberately mislead your opponent, giving you a better chance of success with your mission. If you want, a bunch of really smart guys, Tom Cross, Greg Conti, and a whole bunch of them, recently did a talk on deception for the cyber defender. It's worth checking out. It was at ShmooCon. I thought it was at DerbyCon. You should check out the slides. They're really worth it. For our intents and purposes, honeypot discussions really went in a certain direction around 1989, 1991. Okay, and the two big events that happened at this point, or the two big things, were two papers. Well, one was a paper and one was a book. And the first one I'm going to horribly mispronounce was Bill Cheswick's An Evening with Beerford, in which a cracker is lured, endured, and studied. Okay, and in it, Cheswick, who was working with a whole bunch of smart people, Shimomura, Vitsavenema, effectively spoke about tracking down an attacker who had broken into his network. Okay, and at the time it was really simple. He faked system scripts so that he could see what the attacker was trying to do. It was one of the first well-documented cases of using a honeypot to understand your attacker. What's really interesting is that in his conclusion, Cheswick asks, he says, I wondered how much effort this was all worth. It was fun, but what's the point of all of this? And later on actually gets to the point where he says it was educational and stuff, but actually it was too hard to get it right. Okay, and already you start to see a dark future for honeypots that way. The Cuckoo's Egg, which came up next from Clifford Stoll, quick show of hands, how many of you have read The Cuckoo's Egg? Okay, we're hitting about 50-50. It's super interesting. It was written way back in '89, but it's actually dated itself really well. Almost as an aside, if you go through it, you'll find some really interesting themes. Like it starts off with the disclosure debate. Like if you find a bug, should you tell people about it or should you keep it secret? The next theme that it hit on was questions on the NSA and did they weaken crypto deliberately? One of the other themes that it hit were, and this one's useful for us, something that says most attackers don't succeed because of attacker sophistication. They just poke at the obvious places and get there through persistence, not wizardry. Okay, and like I say, it's held up surprisingly well. One of the big themes to come through was him complaining when he figured out that actually Robert Morris at the NSA knew about all of the bugs they were being exploited with. And he essentially said, well, hold on. The NSA knows about all these bugs. They're letting us get attacked. How does that work? Okay, and it's a theme that's still pretty prevalent today. But for our interests, the thing that was interesting was actually Clifford Stoll's partner who came up with the idea of using a honeypot. Okay, they had this attacker who occasionally breezed through. She said, let's put out some files. Let's create files that look like valid files that he'd be interested in. And let's see if the attacker actually goes for it. Okay, so it kind of gave us the start of honeypots as we know it. Around 1997, Fred Cohen released the Deception Toolkit. And then in 2000, the HoneyNet project really kicked into gear. Okay, Lance Spitzner did lots of good work, and lots of us who were working in the industry around then kind of got really useful information from the Know Your Enemy series, okay, in which the HoneyNet's stated objective was learning the Black Hat community, understanding their tools, tactics, and then sharing all of the lessons learned. Now, if we're talking history, there's the bit that says that's distant history, and that was all of the honeypot stuff. We want to talk really super quickly about more recent history. Okay, and you'll see these on almost all the presentations that you see, so I'll blitz through them. You guys know the numbers. Target were taken. The attackers sat on their network for months before they even knew they were. RSA were attacked, didn't know about it till their crown jewels were gone. The guys over at Belgacom didn't know they were compromised till the reporters showed up to ask them how they felt about being compromised. Okay, and that stuff's pretty consistent. If you consider even the NSA didn't know about Snowden's breach till Snowden was well away. Same deal with the OPM. It should give us at this point hold on, both these things don't make sense. We're saying that there's technology that helped people find out when they were compromised, yet today people are being compromised for months or years and not knowing that it's happening. Something's wrong here. And the question that has to come up then is, if honeypots were a reasonable answer, why did they stumble? Why didn't they make a better showing for it? And we say they stumbled. I guess an honest question has to be asked, did they stumble? The quick heuristic we're using there is the honeypots mailing list. That graph shows activity on the mailing list over time. You'll notice it hit high in 2003. Hasn't been doing much since then. But what we want is to look at the reasons that honeypots have been faring badly. Okay, so we've got a bunch of them. I'll go through really quickly. The simple one is, it just doesn't demo well. I come to you, I drop down an IDS, I put it on your network, it's going to show you stuff immediately. I put down an IPS, I put it in front of your firewall, and it's going to show you stuff immediately. Part of the joy of the honeypot is saying, listen, you shouldn't get a lot of alerts, it's only when it really matters. So you plug it in and then wait. Okay, and somehow that's just not an impressive sales technique. Okay, the other thing is that the honeypot isn't preventative, and people for a really long time were still hooked up on preventing all the things. Okay, nowadays more people are starting to come around to, you're just not going to, you need to detect and contain. The other thing is you're selling to defenders, and by their nature, defenders have thousands of fires that they're trying to put out at any given time. The honeypot kind of easily gets ignored through all this. The third one is the one that I find particularly interesting. One of our theories is that honeypots were sold badly. And I don't mean sold in the money sense, I mean they were pitched badly. If you look at academic papers today, you'll find that honeypots are heavily overrepresented. Anyone doing their masters, even guys at the honors level, want to know what to do. Either you put up some Wi-Fi stuff or you put up a honeypot and track results. And it's kind of interesting that if you watch the early HoneyNet papers, all of them kind of unknowingly aimed at this academic bent. It was, let's try to understand this. Let's do research into the tactics. And the whole technology seems to have pigeonholed itself into people who are doing research, trying to study other people. Something we forget from the Cliff Stoll example is that he had a really specific need. Someone was coming into his network. He wanted to know what this guy was doing then. And so for him, studying the attacker made sense. I'm guessing for most of you, studying the attacker is not what you need to worry about. What you need to worry about is, when has really bad stuff happened on my network? And so all of this kind of pushed it into one direction, and it kind of became the redhead stepchild of InfoSec. And in 2002, do you guys remember this talk? Okay, some of you will. This was Gobbles at DEF CON giving a talk called The Wolves Amongst Us. And it's kind of interesting because they dedicated a whole bunch of their time specifically to picking on the HoneyNet project. They actually called people from the HoneyNet project up on stage to publicly embarrass them. And part of what they did was say, well, look, well, actually, I suspect we can...
Projects, the ones that we're learning and catching are the kids. They're really stupid, fucked up, can't figure out how to even install a rootkit type kids. The black hats that know what the fuck they're doing, they're not gonna be next vision. Wait, here's a go. Project HoneyNet has been around for 3 years now, I think. Have they discovered a single unknown vulnerability being exploited in the wild? What? I think like half of one. Where's the Ode? And you have to...
So what's really interesting about that video is even RFP, who was up on stage there on the right, goes to defend the HoneyNet project by saying, look, we're not trying to catch serious black hats. We're just trying to catch the kids who don't know what they're doing. This is just an exercise in studying what the underground does. And Gobbles then goes on to say, well, hold on, like we don't care. If there's kids doing kid stuff, stop talking like what you do actually matters. Okay, so our thesis really quickly is that we desperately need them to come back. And probably the biggest reason for this is because we can't keep going on with people only finding out they breached when Brian Krebs calls them. Okay, the Verizon DBIR report gives a ridiculous statistic. Back in 2012, 92% of the companies that were exploited or compromised only found out about it when a third party told them that they were compromised. And if you think about it, this is kind of predictable. If you consider the game that you're playing as a defender as a game of chess, currently the big problem that you have is that you only see half of the board. You don't have any visibility into what the attacker is doing. And when we talk about bringing in the honeypots, we're not saying that you're suddenly going to get 100% visibility into what they are doing. We're just saying, let's make that board look a little bit different for them too. Okay, let's introduce something on the board that makes them have to work a little bit harder. Invariably, what the introduction of honeypots does is messes with the traditional asymmetry problem that people talk about. So forever, defenders have been saying, the problem is they have to defend all the time and attackers only have to win once. Okay, with honeypots, what you're trying to do is trying to capitalize on the fact that once someone's broken into your network, that asymmetry now turns around. He's going to stay away all the time. He's going to keep clear all the time. You just have to catch him once, and you then are in a position to burn his TTPs. So given all of this, why is it still rare? One of the things, or the reasons we come up with, is mainly a list of arguments. There's a list of sometimes reasonable arguments on why people will or won't go the HoneyNet route. We're going to blitz through some of them, and in answering them, we'll show you some of the tech that we've built. The first one, and almost everyone says this the moment you talk about building defensive tech, is, isn't this just going to be an arms race? You're going to start an arms race. You're going to do a honeypot and attackers are going to try to figure you out. So martial military terms are overused. I just want to make it clear, this was the definitive arms race. Okay, this is the number of warheads between the US and USSR. And at that point, at their peak, we were looking at about 40,000 warheads. This is the USA versus Korea, okay, who currently have an estimated maybe 30 warheads. This is not an arms race, okay? What you're looking at here is two people having technology. When you consider networks getting attacked today, it's not an arms race between defenders and attackers. When OPM manages to be hacked for a full year before anyone knows about it, when technology companies like RSA manage to lose their crown jewels, it's not an arms race. That's already lost. What you actually want is to at least make it an arms race, where you at least at the table, making them work a little harder for their money. The second argument that constantly comes up is, if I drop your honeypots in, is it going to now introduce new risk to my organization? Okay, and there's a bunch of things you can do about this. For all of the technology that we'll show you today, we've built it in Python, so it's memory safe. We support only minimal protocols. And one of the simple technical things that we say is, it doesn't matter if your honeypot gets compromised, as long as it manages to shoot off one alert, okay? Because if it gets off that one alert, you're in a better position than you were yesterday. But besides for the technical answers, I'd actually like to answer this on a slightly more meta level, which is when someone tells me, won't your honeypot introduce risk into my organization, I almost want to scream, come on. Like, let's be serious. We all know that your organization actually has an old NT4 box that nobody's got around to patching. You've got a bunch of boxes still vulnerable to MSO8 all over the network. But when you're having this conversation on should I use honeypots, suddenly you're the most pristine network that can't handle a single box that'll maybe get compromised, kind of. Okay? And this actually points to a bigger problem. It's a problem that hurts us in security. Fairly recently, I was trying to convince an organization that they should be deploying Emmet, Microsoft's Emmet all over. And one of the guys on their team is a really skilled reverser. And he came in and he told me, I can bypass Emmet. I'm like, sure you can, but you guys have boxes that are so old, you're getting compromised daily, okay? And we need to break out of this almost strange utopia versus reality split that happens when it comes to evaluating technology. And we need to get a little more realistic about it. So the next argument that comes up is the stuff is painful to deploy. It's going to be a lot more work. I'm already struggling to manage all of the boxes on my network. You're now talking about giving me new boxes. And largely, this is the problem that we set out technically to solve. Thingst Canary is a product that we sell, so we won't talk a lot about it. It deploys in 3 minutes. If we're talking about Open Canary today, it's actually got even more of the technology that we use in Canary, largely because we're using it as the bleeding edge. It'll deploy and be useful in minutes. Lots of the stuff that we're going to be talking about should be absolutely super quick to pick up.
So I'm going to introduce now this Open Canary tool, which is one of the tools, one of a few that we're releasing today. In truth, the term Open Canary encompasses a number of these projects, but it also refers to the main tool in the suite. And to kind of define it, so we've defined it as a mixed interaction honeypot. And it's a bit of a weasel word to say it's mixed interaction, but the reason for that is there's both high and low interaction components, but there's also part of it which doesn't fit neatly into either of those models. So if we have to name it, it'll be mixed, but hopefully I'm going to show you parts of this which you wouldn't typically find in either a high or a low interaction honeypot. As Harun's mentioned, it's something we've written in Python, so it reduces that risk component. And the thing that we're particularly focused on, and Harun's touched on it, is this idea of having one alert that comes out of the system. So to have high quality signals. There's no point in having a setup that is, giving you, like, you come in the morning and you go through your canary alerts and then you ignore the ones which are false alarms. Like, that's not what we're aiming for. We're aiming for those high quality alerts. So we want this thing to be extremely easy to deploy, and we'll touch on this again, but when you get into those arms races, if you can reduce that cycle between the attacker figuring out what a honeypot looks like and introducing fingerprints for it, if the defender has a cycle which manages to patch that quicker, then the defender wins. So easy update, easy deploy becomes a big part of this project. And so we see these things as sensors. In other words, you have a bunch of these things. They're really easy to deploy them through your network. They provide a feed of events which get coalesced into incidents. And you can install this standalone, so you can have an Open Canary install which pings you on every event. But the ideal one includes a tool that we call the correlator. and that will let you get very high quality signals. So I'm going to show you a demonstration of the installation and configuring of a basic MySQL Open Canary instance. Okay, so we've got two terminals here. There's attacker in red, and the defender or the sysadmin is here on the blue terminal. And so the attacker somehow comes across a machine on the network, which happens to be called Canary, runs a scan. There's no ports open. The defender wants to install at some point a honeypot, and so decides to go with Open Canary. And so because we're using Python, what I want to highlight here is that we use sort of the standard Pythonic ways of doing things. It's packaged as a Python PyPI package, so that means it's pip installable. Pip gives you, if you're not familiar with it, essentially it handles package dependencies and all of that. There's a sort of a distributed mirroring system for these packages, so you can simply cron job an update. And so you can keep up to date with your Open Canary really quickly. Okay, so that's the install of Open Canary. The configuration occurs via a JSON file. So all of our So we can simply enable the MySQL module, which is already enabled in this one. But what you'll see from, if you quickly scan that, you can alter banners and ports and what you would kind of expect to find on most honeypot software. So we start our honeypot. So the little bit of hand waving that I'm going to do at this point is there's a correlator already running in the background. Its configuration is also quite easy. So essentially that just gets an email address to alert to or a mobile number. And so we've got ours set up to alert to a mobile and to email. So what you'll hear during the presentation hopefully are the alerts coming through on the mobile as well. So we've got the Open Canary running now on this defender's host. The attacker scans the host again at some point. We now see there's an open MySQL. If the attacker decides to do a version scan, then again you would get the banner that comes out. So this now starts to look like a MySQL instance. So at this point, the attacker decides they want to log in. So this could be a physical or a manual login. This could also be a brute force of some kind. Tries to log in, and at this point the Canary has picked up the login attempt, and what we should have is an alert that comes through. Okay, so can we get the podium mic volume up? So the alert came through on the phone. Podium mic? Hello? No. All right. Thank you. All right, so we'll get the other ones that come through, but we'll also see the mail that's come through this side. So there's a MySQL login attempt that's happened. All right, so very quickly we can reduce that cycle for deploying a Canary and getting sort of real incidents that we care about. They come through quite quickly. So that's the MySQL demo. One of the reasons that we've written it in Python, and it's based on the twisted framework, so if you're familiar with Python, that'll mean something to you, is that it makes it really easy to write modules, it makes it really easy to extend. So by way of example, the SIP module that we've got, again, it focuses on things that you care about. And if someone is scanning your network inside and is trying to issue SIP requests to random hosts, that's something you want to be aware of. So the SIP module doesn't have to employ or doesn't have to try and understand the full SIP protocol. You want to know if someone is trying to do SIP stuff inside your network, this thing will tell you. And the module's 18 lines of Python. And so it becomes really easy to extend and really easy to add new modules. The kinds of modules that we have, they're listed there, and most of those will be familiar to you. I guess the one which we want to just mention briefly is having Git. So if you're a dev shop, you might have a Git server inside, and your source repos are something that you want to protect. You want to also be aware of someone who is trying to find Git servers inside your organization, that's certainly activity which you would want to be aware of. So each of those modules has different kinds of triggers that we consider to be high quality alerts. Failed logins are a strong one. There's other examples. So within NTP, if someone is issuing monlist commands to your NTP servers, that's often a technique for recon inside organizations. We've spoken about SIP. And then the final one there is one we'll do a demo on, but it's essentially Samba and file read. So if someone is scanning your internal shares, you can deploy through OpenCanary a file share that has files on it, and if someone tries to read those files, then you get notified. Because it's Samba, it means that you can tie it into Active Directory, so this thing can even exist in a domain. So if someone's browsing your network via a Windows Explorer and through the network browser, then they'll come up, or your canary can appear there. So I'm going to demo then showing you what running all the modules looks like, and then I'm going to show you 3 specific modules from this. Okay, so my run script just wraps up starting Samba and a few other things, and it also has a separate config file. At this point, the OpenCanary service is running. If the attacker now scans that same canary, there's a different configuration. There's now a bunch more modules that are accessible to them. And so the first one that we'll look at is this file share. So you have someone on a Windows machine, they're browsing the network, they come across this share on the network, it has a few files, they open up one of the files, they get to see the contents of the file, but at the same time we should get an alert that comes through. All right, so there's your alert that comes through as soon as that file gets opened. In the same way, what we can do is we've integrated a project. There's a separate project called RDPi, which gives you an RDP or Windows Remote Desktop honeypot. And there's a lot of cool stuff that is possible in this one. So this for us is still a proof of concept, and it's sort of on the leading edge of where we're going. But you can connect to the canary. It gives you an RDP interface. What it's actually showing you at this point, and this is straight from that project, the RDPi project. So that's the attempted login. That happens with the credentials sent with the initial connection to the RDP server. What it's actually showing you here is a video, so a screen cap of a previous RDP instance. So we're not connecting to a Windows server, we're connecting to Twisted, and it's essentially looping a video of what an RDP session might look like. And so we can capture keystrokes at this point and determine if they're trying to brute force passwords and so on. And then the final demo I'm just going to talk about, but we can also, there's a VNC module, and so we can capture connections, again, failed logins against a VNC instance. Okay, so we integrate those projects, RDPi, Kippo, and Samba, and we give shots to all of those guys. So this project is open source. OpenCanary is open source. It's available at opencanary.org. And that code is there. With the correlator code still needs to go up, but it'll go up in the next day or so. So that's hopefully put to bed the idea that they're hard to deploy. The next argument is that they get noisy. So you've just got another device that's spitting logs, and no one's going to look at those. And one of those, if you remember, we refer to our canaries as sensors, and sensors can get noisy. So the correlator is then that component which accepts feeds from multiple canaries and coalesces them. So for example, if someone conducts a brute force attack against your MySQL instance, the canary is going to issue an event for every authentication try, but actually that's all part of the same brute force attack. And so we don't build that logic into the open canary, we keep it as simple as possible, but that logic is then built into the correlator. And that allows you to do things like detect if someone's scanning for a single port but across your entire network, deploy multiple canaries through the network, And you can, with the feed that's coming back from them, you can easily figure out if someone is scanning across your network. The next argument is then, well, is the attacker ever actually going to bump into it? And we can phrase this a bit differently to say, well, how can you lead an attacker to your honeypot? And so it starts to get into a thing of discoverability. How can you make, or how can you lead, or how can you help attackers find your honeypots? The attackers in your network have a lot of targets they can aim at, but you want them to actually focus on your honeypots. And so there's sort of two factors that we think contribute towards discoverability. The one is references, and the other one is density, honeypot density. And why you want to focus on this is because if an attacker is only conducting passive recon and your canary is staying quiet, then there's a good chance they just never find it. So when we say that there's two factors, density and references, what we mean by references are, a reference is any artifact that leads an attacker to your honeypot. So it could be a config file entry, it could be a packet on the network, it could be an entry in one of the directory services, but all of those are references that point to your honeypot. And you can distribute references throughout your organization. The other option is you can also increase the density of your honeypots. You can have more honeypots. And if they're easy to deploy, and if there's if it's trivial, like as we've made Open Canary, then you can really spread them out. And so now an attacker randomly probing the network is likely to come across one of your honeypots. So it leads us to this completely made up graph, but the point that we're trying to get to is that there is some kind of trade-off, but they're orthogonal to each other, exactly as the graph says. So we've got references and density, and there's some kind of optimal honeypot deployment that you can aim for, some kind of efficient deployment. And we have a suspicion it looks something like that. You can have lots of references with few number of honeypots, or lots of honeypots without a lot of references to them. And of course you can have lots of references and honeypots, but then that's just probably inefficient. It's probably more expensive than you need to be. So within Open Canary specifically, we get to this issue of discoverability. And out of the box, Open Canary supports a few discoverability options listed there, but it's essentially what you'd normally find, the kind of traffic you'd find on a network. And we think that it's possible to do more. So for this particular topic, we think that your canaries should be producing more than the services necessarily that they've got running on them. And we've got a sort of a research tool that I guess we'll also push out after this, a thing called a Hardidar. I don't know if that's an international term, but it's sacred ibis is that bird. In South Africa, we call those things Hardidars because of the noise they make. And they just essentially very loud things. And so this tool is an attempt at making a tool that attracts attention to a given host. And so it does how you would imagine it to do, or it does what it does in the way that you probably imagine it, that it does it, by essentially emulating a bunch of network protocols. There is one other way that we think that it can work. So if you sniff a random Ethernet network on a large organization, if there's mild congestion even, you will see packets from hosts that are not your own. So you'll see TCP packets, and those packets they'll be in the middle of someone else's stream, and the switch, for whatever reason, decided you needed it at this stage, and your host ignores it because it's not addressed to you. If someone's sniffing the network, they've seen those packets. So what Hardidar will do is generate those fake packets, and essentially it can insert interesting bits of data. So for example, on a fake telnet or a fake packet on the telnet port, it can insert something that looks like a password. And then on your Open Canary, if you see that password being used, well, then that's a very curious thing. Someone's sniffing the network and trying to pull out content. There's some drawbacks to this. Essentially, that tool can be fingerprinted. But at that point, talking about that asymmetry problem, if you know that a fingerprint for Hardidar has been built into attack tools, you can make your servers look like Hardidar. And at that point, now the attacker is again in this position where they don't know, is this something that I care about, or is this something that has been put in place to trip me up? So that takes us on to the idea of fingerprinting, at which point H takes over.
So one of the other arguments that always come up here is, and it kind of ties into my earlier rant, which is I can fingerprint your honeypot, therefore your honeypot sucks. Like I can use this technique to figure it out. Todd Beardsley did a really nice talk from Metasploit on discovering Kippo, for example. So now built into Metasploit is a way that you can discover it. And again, there's two ways you can hit this. One is, for change, we can start fighting that fight both ways. Because you can automatically update, or because you can pull updates for Open Canary, you can now have a situation where you actually can respond to those things. You can match them technically. But also, the argument itself is kind of flawed. Okay, the stuff comes up pretty consistently. There's a talk happening at Black Hat this year on fingerprinting and discovering a whole bunch of honeypots. And I'll tell you why I think it's slightly misguided. Way back when Sebek was one of the popular honeypots, so this was in 2003, and what Sebek used to do was allow you to surreptitiously take your keystrokes from your honeypotted machine and send it to another host for monitoring. That was 2K3. In 2K4, at CanSec West, a bunch of really smart guys gave a talk on breaking honeypots. Okay, and what the talk was, they had a whole bunch of ways that you could detect when Sebek was running on a machine. And again, it's good research, and it's research that needs to happen. And the way the guys were doing it was exactly like you'd predict, right? You look for differences, look for subtle changes. Sebek was running as a kernel module, so look for ways that you can detect that there's a kernel module that's tried to hide itself. At the time, they were using Joanna Rutkowska's red pill, okay, so a way to discover that the host was actually virtualized. And in truth, it's kind of not the point, okay? The guys who hit OPM were not running red pill to first see if they were on a Trojan machine. The guys who hit target, they went in, and after the discovery, you find out they kind of ran like bulls in a china shop. Okay, and so again, we need to draw this line between, yes, I can defeat you in the lab, and yes, you'll probably add value because you're going to pick this up on a real network. Both those things are not the same, and we keep confusing them almost as if they are. So one of the other arguments that always come up is, look, a honeypot is a nice to have. We think we'll get to it someday, but first we've got to do all these other things. Tom Cross recently went on a little Twitter tweet storm about it, essentially where he said, look, there's lots of other stuff you should do first. Most people don't get deception. Worry about it later. Okay, and you can go and read the gist of it, but essentially he was saying, sort out everything else, then worry about your honeypot stuff. And I had a discussion with him, and essentially one of the things that you need to consider here is when you say it's a waste of time, that only matters if the time you're talking about is a lot of time. If we're saying you can get Canary up and running in 3 minutes from the unboxing, or Open Canary up in 5 minutes, then I'm going to say you can't really say it's a waste of time. Don't get coffee this afternoon, and you're done. Okay, as long as your canaries don't add extra overhead to your day-to-day activities, if you can drop them and forget about them until they're actually warning you about real attacks, it's actually a non-argument. So if we're saying canaries installed in 3 minutes, Open Canary installs in 3 minutes, we're actually asking now if there's anything we can do that's quicker than this. And what we're going to touch on here are canary tokens. Again, not a new idea. Back in 2003, Lance Spitzner was talking about honey tokens. Eugene Spafford and Kim were talking about it in '94. And actually, it's a pretty ancient concept. So I'm not sure if you guys know, but way back when people made money selling maps, what they do is put in fake cities on their maps. And if your fake city showed up on someone else's map, you then know that he copied your map. The city of Agloe there is kind of interesting because guys actually took a map, went to where they thought they were on the city, then named their shop of Agloe, and a whole city actually built around the shop. So a fake city actually sprung up, a real city sprung up where a fake city was. But essentially it brings us to what we're going to talk about here in the form of canary tokens.
And so again, the idea here is pretty simple. We're going to have a sort of a unique tag or a unique piece of data, and we're going to embed that throughout our already existing network. So Open Canary is to say, here is what we can do when we have a fake set of services. Canary tokens are the way that you can start to deploy detection into an already live system. So we've got a number of channels that these things can be triggered over, and sort of we'll talk about them in a little bit more detail as we get them. The alerts that come through, again, they're going to come through on the mobile. So if you hear that message received signal, that's the alert coming through. I'm not going to be showing you the full alerts. We're a little bit short. So really basically, or really simply, so Canary Tokens is currently live. So that site is there, canarytokens.org. We can create a token. It's going to come back with a generated token in a bunch of different formats. One of them is sort of a standard web bug. So the standard web bug is something that you would have experienced with spam and those sort of things. It's a unique URL. If someone hits the URL, we'll get that alert. Right. All right, so there's the alert. It says that someone hit your web bug. All right, so that's what an alert looks like. I'm not going to be coming back to the alerts for the next little bit. But the web is just one way that we can detect these tokens. So we can embed it in a URL, which might get distributed, but we could also, for example, embed it in a DNS channel, right? So we could embed it in a DNS hostname. If that hostname ever gets queried, then that fires the alert. And I'm going to skip this demo. I think the concept is pretty straightforward. We have a token, it's in a hostname. If that hostname ever gets queried, the query comes back to our DNS server at canarytokens.org, and we know that someone has been looking up this hostname. And why that's important is we use it as a building block, and it gets used as a building block on some of the additional channels. So these are the channels that we support that are currently available. On the output side is email and SMS. And on the input side, we've got HTTP DNS, which I've spoken about, SMTP for generating fake mailboxes. And then there's also Imager, LinkedIn, and Bitcoin, just to sort of throw a few mixtures in the pot. And what we're trying to show there is the kind of thinking that we can have when it comes to Honey tokens. So Imager in particular is an interesting one. If you look at that honeypot, if you look at the Honey token web bug that I showed you, the argument against it is that, well, I just need to set your canarytokens.org domain in my host file to 127.0.0.1, and then I'll never trigger any of your Honey tokens. So what we introduce here is a level of indirection. We say, well, what we'll do is we'll monitor an Imager file or an Imager link. Imager is an image hosting site. And so we can monitor an image on that site, and if the view count ever changes, then we know someone has tried to hit that link. And so the Canary token in this instance is actually an Imager file. If you're going to block Imager, like how are you going to look at your cats? So like you need Imager, and you're not gonna block that one. So we can start to use indirection for Canary tokens, and that way, if someone says we'll block your domains, like yeah, go ahead, block the internet. So this we're also releasing. This is another tool getting released today. We've got a live site at canarytokens.org, so you can generate. You don't need to install it if you don't want to. But what we strongly recommend is pull down the code, or in fact to make the deployment even easier, we've released Docker images. So register a few domains and you can be up and running with your own Canary tokens. We can take these tokens now and start to find funny ways in which they can be applied. And so part of it is, well, how can we use them to spot attackers on a network? If that's the building block, what are the actual nuts and bolts where we're going to use these Canary tokens? And we've got a list of places that we think they can be used, and we'll start to walk through them. So the first one is we want to try and examine, we want to be notified if anyone tries to read a particular file, a sensitive file. So for example, if you happen to be the manufacturer of, let's say, security software, and you've got a number of source repos and they all look, so we've got a bunch of source repos here, and you want to know if anyone ever tries to read any of your source repos. You can do this via Git hooks or some other version control system hooks, but if someone gains direct access to the server, then you're not going to get notified via that hook. So what we do is we generate a token. This is a DNS token. The defender runs this little tool called Canarify. He can specify a process name to hide it if he wants. We paste in our token and we point it at the file that we want to be notified if anyone ever tries to read that file. Okay, so we're watching this particular README file. At some point, that server gets compromised. Here's our attacker in red. Attacker goes into that particular directory. They're exploring all the repos, and they cat that README file. They don't get any notification. Obviously, they still see the file. But what we'll find is that triggers the canary token, and here is our Canarify token that gets sent. So you'll also see that loop is extremely fast, right? File read happens, we get in the alert within the time that we can't even switch to. Okay, so we can do the same thing in OSX via a different mechanism. We can do it via a dtrace script, but again, the idea is file read happens, we trigger the token. We can do that for process running again in OSX as well. So process gets run, that might be a particular whitelisted process, a blacklisted process. We get notified when that process runs. We can do the same thing in Windows, but for directory browsing. So if we want to find out if someone is snooping around the network, we showed you a way to do it in OpenCanary, where you deploy a fake file server. This is interesting because in this method, you can take your legitimate file server, deploy a file to the server, and if anyone tries to read it, you get notified. And the way that we do that is we reuse desktop.ini. So if anyone ever qualified on like Windows 3.1, you might be familiar with desktop.ini, but essentially the sum of it is if someone goes into a folder that has the desktop.ini, it's going to try and load an icon from a path that we specify. That path is a UNC path, which is a network path. UNC paths can contain domain names, and so we can get a ping back if someone simply browses into a directory. Okay, so that's what the desktop.ini looks like. So I'm going to skip that particular demo, but the idea there is that you browse into a folder and you get a canary alert. So it means no integration for no additional login, no additional audit, no additional agents or anything, but you can still be notified when people are poking around. That same technique works for zip files. So zip, WinZip and WinRAR will happily unzip desktop.ini. So you can, in this way, figure out if someone is unzipping particular files. In terms of databases, we can deploy canary tokens into databases as well.
Real quick.
Yeah, so for making the theoretical possible, essentially here what we're saying is we've got a way that we can detect if someone is querying a table in a SQL Server database. That advice is something that you will hear in from lots of people, like just deploy a honey token into a database and figure out if someone queries it. Try and do it. It's a little tougher than you think it is. And so we've got a method where we can essentially trigger a stored procedure when someone looks at a view. The view might be something like user passwords. So if an attacker is browsing your database, they try and select from that view, you get ping back in your canary token. MySQL is a different, or has an additional complexity. The problem here is we're trying to track failed logins, and MySQL only writes that information out to a text file. It doesn't give you any trigger inside the database. So it produces, or it gives us an alternative way to start to trigger canary tokens, and we've got another piece of software we're releasing today called Canary Token D, and it's a generic log file tailor. So it'll tailor a log file and pull out lines that you care about via regex, and then trigger a canary token from that. So the setup, it'll step you through the setup. The attacker tries to log into the host, and you get your token. Again, we can start to use these tokens in files as well, so you'll be familiar with the idea of Word files that ping back, so I'm not going to spend too much more time on that, but Canary Token supports those. We also do it for PDF, and why I like this particular example is that Adobe Reader, there's essentially a cheap trick that we can employ with Adobe Reader, but the sum of it is we can get notified if someone opens a PDF file in Adobe Reader, regardless of whether or not they allow or disallow the network communication. So and that's in how Adobe Reader handles DNS responses. So the user would see a pop-up, but by that time you've already been notified about the canary.
So we're about to get kicked off the stage. I'll be really quick. Once you've got the building blocks, like we said, you can start to do more and more creative, tiny things with them. One of our clients, for example, kept having their web pages copied for phishing attacks. We can now insert JavaScript onto that page that says, check when you are loaded, check whether you're running on client domain. If not, fetch this canary token. So now anytime their page is copied, the first person who surfs to it actually notifies you that your site is no longer running on your domain. There's a whole bunch of things like this. It allows you to get a little bit sillier. Like Marco says, if we're tracking LinkedIn, you can create a fake network admin, use the canary token, and then get told when someone's looking at your fake admin's profile, the only way they'd get to him is searching for network admins at your org. And the last one that we thought was kind of cute and is worth quickly mentioning here is using advertising networks as a sort of canary. So what you'll see we did here is created a quick hash. We then go to Bing adverts, and I'll tell you why we use Bing, and we bought that AdWord. Okay, so we said if this hash ever shows up in a search, we want to run our ad on it. Bing actually allows us to go a little further and tie I'm willing to bid any money for this, just bid the money and mail me. So they become our canary for us. And then you'll see when someone searches for the hash, you'll actually notice that's our ad showing up there that says, okay, you have problems or you have extremely bad luck. And essentially we then get a view count increase in our ad service, and Bing is nice enough to mail us to say, listen, we ran your rule. But essentially it means that your canary was now picked up, someone searched for it, and the only reason they searched for it was because bad stuff has happened. So to wrap it up, the last two arguments almost meld together. People say, look, this honeypot stuff is cute and it's fun for research, but it's not enterprise grade. Again, really simply, our canary stuff we sell. So it's out there. We've got it running on networks all around the world. We've got happy customers with it, so clearly it's not just for fun. And the last argument that comes up is not another one, okay? Because if you look, there's actually a ton of guys who've built honeypot tools at some point or the other. And if you actually look at this, you'll find that lots of them have died. HoneyD was excellent, and the last time the code was touched was 2007. There's projects that haven't been touched since 2003. And essentially what we're saying here, as strange as it sounds, is we're making money off our canary stuff. So we are heavily incentivized to keep on development. So Open Canary is not going to go away anytime soon. We need it. It's important to us. We're giving it to you guys free. You should use it. So parting thoughts, canaries, honeypots are a good idea that have largely been ignored for the last bit. Detecting infiltrations months or years after the compromise is increasingly inexcusable. I think boards will forgive you for saying we got owned, people get owned, but being able to say we got owned 2 years ago and only found out about it now is getting hard to defend. Canary, Open Canary, Canary tokens, literally your investment time-wise is minutes, which means you really shouldn't have an excuse for getting caught with your pants down 2 years later. Other than that, all of the stuff, all of the URLs are up there for you guys to use the stuff. Marco and I will still be around. I'm not sure if we have any time for questions.
Same.
No?
Same. Wrap it up.
Thank you very much. Yeah, you guys can drop us a mail or ping us on the Twitters or grab us now. Thanks a lot.